Hello everyone, I am Trupti Vidwai working as an IT engineer at IPCS Global Nagpur. Today we will cover one of the important topic of deep learning, which is CNN, that is Convolution Neural Network. In this video, first of all, we will learn what is CNN, what is the architecture of CNN, how it works on the images. But for that, first we have to understand what is an image. Then we will learn how convolution layer works on the images. Then we will see what are the application of CNN in the real world. At the end of the video, we will cover how CNN can be implemented on the image dataset using Python code. So let's start. CNN is a type of deep neural network. It is used for image classification, object detection, and image generation. A CNN typically consists of several layers. Each layer has its own specific function. So this is the architecture of CNN. Architecture of CNN consists of different layers, which are input layer, convolution layer, pooling layer, flattened layer, fully connected layer, and the output layer. But before going into the architecture of CNN, first of all, we have to understand what is an image. So this is the image. Actually, image is basically made up of the pixels. So on the left hand side, this is a black and white image. So in this image, 0 pixel value represents the black color and white pixel value represents the white color. And on the right hand side of the image is an RGB image, which consists of 3 channels, that is red, green and blue. So this type of image is given to the input layer of the CNN architecture. Then on that image, kernel or a filter is applied on the image in the convolution layer. So in the convolution layer, the image or the kernel are undergone a convolution operation. So in convolution operation, at each position, the filter multiply its weights by the values of the image it overlaps with, sums the result and produces the single value. Output value for this position. This process is repeated across entire image. The output of the convolution operation is called as the feature map, which represents the detected feature in an image. So here, this 6x6 RGB image, which consists of the 3 channels, is convoluted with 3x3 filter. So we get the 4x4 output image at the output. So how we get this output image 4x4? For that, we have to understand the formula for the output image. So in the formula of the output image, N represents the size of the input image, F represents the size of the filter. So here, size of the input image is 6 and the size of the filter is 3. So this, after putting these values in our formula, we get 4 at our result. So that's why we get the 4x4 image at the output. So the next layer is our pooling layer. So pooling layer reduces the spatial dimension and return the important features. It helps in reduces the computational cost and helps prevent overfitting. So there are 2 types of pooling layer, max pooling layer and average pooling layer. So in this image, 2x2 filter is considered with stride 1. So stride is here step size. When 2x2 filter is considered, then move on this image, we get here the maximum value as 237. So this value is considered our first pixel value. Then again 2x2 filter is moved on this 2x2 area, then we get the maximum value as 237. That is our second pixel value. So in this way, we have to move this 2x2 filter on the entire image and we will get an image at that output where we have considered only the maximum values. Then if we consider stride 2, then we have to first move this 2x2 stride on this area. Here we get 237 as the maximum value. Then again on this 2x2 we get the maximum value 223. That is our second pixel value. So in this way, max pooling operation is performed. Then second one is the average pooling. So in average pooling, we are considering the average value in this cell. So average is what? 2 plus 2 plus 9 plus 4 divided by 4. The average of this 2x2 is 4.25. Then again we have to consider the average of this 2x2. Then we will get the average to 4.25. So in this way, we have to calculate the average values of for the whole image. Then the next layer is our flattened layer. So in flattened layer converts the our two-dimensional image array into a one-dimensional array as shown in this image. Then next layer is our fully connected layer. So one or more fully connected layers are also known as the dense layer, where each neuron is connected to every neuron in the previous layer. So this shows the fully connected layers. So next layer is our output layer. The output layer is a fully connected layer that has many neurons, as there are possible classes in the classification problem. So if we have binary classification, then we have to consider one neuron, and if we have multiple classes, just like for example I have 10 classes, then I have to consider the 10 neurons at the output layer. So if I have the binary classification, then I will consider sigmoid activation function at the output layer. If I have 10 classes at the output layer, then I will consider softmax activation function for the multi-classification problem. Then we have to see what are the CNN models which are predefined in our Python. So these are the predefined CNN model, which are AliNet 5, AlexNet, VGGNet, Google AliNet, ResetNet, DenseNet, Exception, MobileNet, EfficientNet, and YOLO. So what are the application of CNN in the real world? It is used for image classification, means if I have to classify a image in a particular class, then it is used for object detection, segmentation, face recognition, means I have to detect or recognize the face from an image. Then it is used for styles transfer and in autonomous vehicle. So this is up to the theory of the CNN. Then we have to cover the practical code of the CNN. So let's see our practical code. So for that we have to install this TensorFlow library first of all, and then we have to import that TensorFlow library. Then we have to import layer and model from the TensorFlow. Here we use matplotlib for graphical visualization. Then here we consider the MNIST dataset, which is a predefined dataset in our TensorFlow library. Then we load our dataset here, which is already divided into training and testing part. Next we have to reshape our input training images and testing images into a predefined shape, because our CNN layer accepts a predefined input shape. Next we build our CNN model. In this CNN model, first we consider a convolution layer with 6 number of the filters of size 5 by 5, and activation function is tan h with the input shape 28 by 28 by 1. Then we add the average pooling layer of filter size 2 by 2. Then again we add next convolution layer with 16 number of the filters with size 5 by 5 with activation function tan h. Then we add average pooling layer of size 2 by 2. Then next we add flatten layer, which convert the 2D array into a 1D array. Then we add 3 dense layer. First dense layer with 120 neurons and activation function tan h, another dense layer with 84 neurons and the activation function tan h, and again one dense layer with 10 neurons at the output, because we have 10 classes at the output layer with the activation function softmax, as it is used for multi-classification. Then our model is built. Now we have to compile our model. So for compiling our model, here we consider Adam as an optimizer, loss as a sparse categorical cross entropy loss, and matrix accuracy for the evaluation of our model. Then next we have to fit our training data to our model. Then we have given epoch is equals to 10 and validation data as a test data, x test and y test. Then our model will train our data up to 10 epochs. Then after completing the 10 epochs, we will evaluate our model on the test data. So after evaluating, we get the accuracy of 98%, means our model is working better on our input data. After getting our accuracy values, we plot that training accuracy and test validation accuracy using matplotlib code in the form of the graph. So blue line represents the training accuracy and orange line represents the validation accuracy here. Then next, similarly, we have to plot training loss and validation loss with the help of the matplotlib. So here also Blue line represents the training loss and orange line represents the validation loss. So this is how our model is working, but we have to test it on the number of the images. So here we build a function plot prediction. In this we have given input parameter as a model, our model, x test data, y test data, and the number of the image we are considering. So here we are considering 5 images from our data set. So after giving these images as an input to our model is predicting something in the output. So let's see what is it. Our model is predicting 7 is written in our image, and actually the 7 is written in our image, means our model is predicting 100% correct. Then next, in this next image, model is predicted 2 written in this image and original value is also 2. So in this way we have here consider 5 images. So for this 5 images our model is predicting correct and actual values are also similar as the model is predicting. So this is how our CNN is working on MNIST data set. Thank you.